What's up everybody, it's BZ Boys Tinkerings and welcome back to the channel. Now if you've been anywhere near the 3D printing world, you know things can get pretty techy, pretty fast. We geek out over different filaments, argue over slicing software, and don't even get me started on the endless modifications. But today we're pressing pause on all that to tackle something fundamental to every 3D printer out there: kinematics. Basically, kinematics is how your printer moves, like how that printhead actually gets from point A to point B to lay down those meticulously crafted layers. You might be thinking, isn't it just moving in a straight line? Well, yeah, sometimes. But other times it's a whole orchestrated dance of belts, rods, and motors, all working together to make printing magic happen. Today we'll explore the various types of 3D printer kinematics and how they impact your printing experience. We'll break down the pros and cons, the quirks and features, so you can figure out which system might be right for your next big project, or maybe just win a 3D printing trivia night. So, let's dive in. First up, we have the classic Cartesian system. You know, like that XY graph you probably slept through in high school math class? Yeah, this is its time to shine. Imagine a box, right? Your print bed is down there doing its thing, and the printhead moves along three axes. X, Y, and Z. X moves left and right, Y goes back and forth, and Z brings the heat, literally controlling the up and down or the layer height. Now, Cartesian printers are known for their simplicity. They're relatively easy to build even for beginners, and their straightforward design makes them super reliable. Plus, because the printhead only moves along those straight lines, you often get really precise prints, which is a huge win for detailed models. But like that one friend who's always on time but maybe a little too predictable, Cartesian systems do have their limitations. Since the printhead has to literally travel across the entire bed, they can be a tad slower than some of the other contenders we'll be talking about. Also, that whole boxy design, yeah, it doesn't always scream sleek and futuristic, but hey, if it ain't broke, don't fix it, right? Next up, we're flipping the script, literally. Instead of the printhead doing all the heavy lifting, bed slinger kinematics, also known as moving bed systems, put the print bed on a swing. Think of it like a seesaw with the printhead on one side and the bed on the other. This unique setup means the printhead only moves up and down for layer height, while the bed tilts and swings to create those X and Y movements. This can be a real game changer for printing large objects, as the printhead doesn't need to travel as far, potentially speeding up the whole printing process. However, bed slingers aren't as common as our Cartesian friends for a reason. They can be a bit trickier to calibrate, and that swinging motion can sometimes introduce vibrations, which, as you can imagine, isn't ideal for super precise prints. But hey, for makers who value speed and a bit of unconventional engineering, bed slingers are definitely worth a look. Alright, let's talk HBot. No, it's not a new robot overlord, though it does sound kinda cool, right? The H in HBot actually refers to the system's belt configuration. Picture this. You've got two belts running parallel to each other, forming the top and bottom of the H. The printhead sits on a carriage that rides along these belts, moving back and forth. Now here's where things get interesting. To control the X and Y movement, those belts are driven by motors located on opposite sides of the frame. So by adjusting the tension and movement of the belts, the printhead can zip across the bed with impressive speed and precision. This makes HBot systems popular for applications where accuracy is key, like printing intricate designs or even functional parts. And because the belts can move quickly and smoothly, you can often achieve faster print times compared to some other setups. However, the belt system does require some careful calibration to avoid any unwanted wobbling or layer shifting. Now let's talk Core XY, a system that's all about efficiency and smooth moves. Like HBot, Core XY utilizes belts and pulleys. But instead of moving the printhead directly, this system controls the movement of the entire print bed. Imagine this. Your print bed is basically chilling on a platform that can slide effortlessly along the X and Y axes. The printhead? It's just vibing out, moving up and down for those layers. This setup allows for some seriously fast printing speeds, especially when tackling larger prints. And since the printhead itself isn't being whipped around, Core XY systems are known for their stability and ability to produce high-quality prints. Of course, with great power comes, well, you know the saying. Core XY systems can be a bit more complex to build and calibrate, but for makers who prioritize speed and precision, they're definitely worth checking out. Last but not least, we have the Delta configuration, the cool kid on the block known for its unique three-arm design and lightning-fast print speeds. Imagine a triangular frame with a print head hanging from three arms, each connected to a tower motor. These motors work in perfect sync, adjusting the length of the arms to precisely move the print head across the build area. Think of it like a super precise puppet show, but instead of puppets, you're creating awesome 3D prints. Delta printers really shine when it comes to speed. Since the print head is lightweight and the arms have minimal inertia, they can achieve some seriously impressive acceleration and travel speeds. However, that unique design does mean a steeper learning curve when it comes to building and calibrating. Also, the circular print area can be a bit limiting compared to the rectangular build volumes of other systems. But if speed is your jam, and you're down for a challenge, Delta printers offer a unique and rewarding printing experience. So there you have it, 5 different kinematic systems, each with its own strengths and quirks. Which one comes out on top? Well, that's like asking which filament is the best. It all depends on your needs, your printing style, and maybe how much you like tinkering. Cartesian offers simplicity and reliability, Slinger brings the speed for larger prints, HBOT and Core XY deliver precision and efficiency, and Delta wows with its speed and unique design. The best way to figure out what works for you is to do your research, check out some reviews, and maybe even get hands-on with different systems if you can. Thanks for joining us on this journey through 3D printer kinematics. Hopefully you learned a thing or two, discovered a new system to explore, and maybe even feel inspired to tackle your next big printing project. Don't forget to like, subscribe, and hit the bell icon for more tech insights. Until next time, keep creating.